Hello everyone, welcome to my presentation on machine learning model deployment fundamental. My name is Akash Patel and today we are going to learn one of the most important stage of the machine learning lifecycle, which is model deployment. Many people think that build a machine learning model is the final goal, but that is actually not true. Training a model is only one part of the process. A trained model cannot help anyone until it is developed, deployed, and made available for real users and real applications. Throughout this presentation, I will explain what machine learning model deployment actually is, why it is important, different deployment methods available in Amazon SageMaker, and how organizations use deployment in real world business applications. So let's begin. So before we understand deployment, let's first think about what happened during machine learning. Imagine you are building a machine learning model to predict whether a customer will buy a product or not. First, you collect historical customer data, then you train your model using that data. After training, your model becomes very good at making predictions. But here is an important question. Can customer actually use your trained model? The answer is no. The trained model is simply stored as file inside your development environment. Nobody outside your project can use it yet. This is where model deployment become important. Model deployment means taking the trained model and making it available so website, mobile apps, or business systems can send new information to it and receive predictions results. For example, imagine Amazon shopping website. So every time you search for product, Amazon recommend other product you may like. Those recommendations are not generated manually. A deployed machine learning model receives your shopping activity, analyze it, and quickly predict product that may interest you. Without deployment, this would never happen because the trained model would remain inside the development environment. During this presentation, we will learn different deployment methods, understanding how Amazon SageMaker helps organizations deploy machine learning models and explore where these techniques are used in real business. So let's move to the next slides. So now let's understand exactly what machine learning model deployment means. The a world deployment, the word deployment simply means making something available for practical use. In machine learning, deployment is the process of moving a trained machine learning model from the development environment into a production environment. Now, you may wonder, what is production development? A production environment is simply the place where a real user and real applications use the model every day. For example, during training, a bank may teach a machine learning model how to detect fraudulent credit card transactions, but after training is complete, the model is still only saved inside the bank systems. So customer cannot benefit from it yet. After deployment, the bank connects that trained model to its online payment system. Now, every time a customer makes a payment, the payment information is automatically sent to the deployed model. Within a few seconds, the model analyze the transactions and predict whether it looks normal or suspicious. Notice something important. The model is not trained learning again every time a customer makes a payment. It already learned during training. Now it's simply using a knowledge it already has to make predictions on completely new information. This is why deployment is such an important step. It transforms a trained machine learning model into a useful business application. Organizations deploy machine learning model because they want to automate decisions, improve customer experience, reduce manual work, and make faster business decisions. So let's move to the next slides. So now let's understand why deployment is so important. So imagine you spent several weeks building a very accurate machine learning model. Your model performed extremely well during testing. It predicts correctly almost every time. But after finishing your project, you simply save the model on your computer and never use it again. Even though your model is excellent, it provides no value because nobody can actually use it. This is exactly why deployment is necessary. Deployment allows organization to connect machine learning models with real business systems. For example, a hospital may deploy a machine learning model that help doctor identify possible disease from patient's report. A online shopping company can deploy a recommendation model that suggests product customers might like. A bank may deploy a fraud detection model that check every transaction before approve it. A manufacturing company may deploy to predict maintenance model that warns engineers before a machine breakdown. All of these organizations are using deployed machine learning models to solve real business problems. Another important benefit is speed. Instead of employees making every decision manually, deployed model can process thousands of predictions requests automatically within a few seconds. These save times, improve accuracy, and allow business to serve many customers at the same time. This is why deployment is considered one of the most valuable stage of the entire machine learning lifecycle. So let's move to the next slide. So now that we understand what model deployment is and why it is important, let's look at how the complete deployment process works. Think of this workflow like following a recipe. When we cook food, we don't start with a final dish. We follow each step one by one. Machine learning works in a similar way. The first step is data collection. Every machine learning project starts with a data because a model cannot learn without information. Organization collect the data from many different places such as website, mobile application, business database, customer purchases, medical records, or sensors. The better the quality of the data, the better the machine learning model can learn. After collecting the data, the next step is model training. During training, the machine learning model studies the data and looks for patterns. For example, if we creating a model to recognize spam emails, the model learns the difference between normal emails and spam emails by studying thousands of examples. Once training is complete, we move to model evaluation. This step is very important because we want to make sure the model is accurate before allowing real user to use it. Engineer Engineers test the model using new data that was not used during training. If the results are good, the model is ready for deployment. If not, the model training may need more training or improvement. And after evaluation comes model deployment. This is the stage where the trained model is moved into a production environment using service such as Amazon SageMaker. Once deployed, application can communicate with the model, the request predictions uh, whe- uh, whenever they need them. The next step is real-time predictions. Imagine you are using an online shopping website. Every time you search for a product, the website sends your information to the deployed model. The model quickly analyzes your activity and recommends products you may be interested in. This entire process usually happen within just a second. The final step is continuous monitoring. Deployment is not the end of the machine learning journey. Organization continuously monitor the deploy model to make sure it is still providing accurate predictions. If customer behavior change or the model become less accurate, the engineers can retrain the model using new data. So the complete workflow is collect data, train the model, test the model, deploy the model, generate predictions, and finally monitor the model to keep it working well. Let's move to the next slides. So now let's talk about one of the most common deployment methods called real-time inference. The word inference simply meaning means using a trained machine learning model to make predictions on a new data. Real-time inference means that the model receives the information and immediately return a predictions. Think about using Google Map. When you enter your destination, you don't want to wait 10 minutes to see the route. You expect the results almost instantly. Machine learning works the same way. When the application sends the new information to a deployed model, the model processes that information immediately and send back a prediction within a few seconds or sometimes even a milliseconds. Amazon SageMaker provides the feature using sometimes something called a managed endpoint. You can think of the endpoint like a receptionist. Whenever someone arrives with a request, the receptionist receives the request, send it to the correct person, and then return the response. Similarly, a SageMaker endpoint receives predictions request and send them to the deployed machine learning model and then return to the prediction back to the application. Real-time inference is commonly used in many applications that require a fast response. For example, if you make an online payment, a fraud detection model quickly check whether the transaction looks suspicious. If you open Netflix, the recommendation model instantly suggests movies based on your viewing history. If you ask a chatbot a question, the chatbot immediately generates a response. These applications cannot make user wait several minutes. They need immediate predictions. One important advantage of real-time inference is speed. However, because the endpoint is always running and ready to receive requests, organizations also pay for computing resources even when very few requests are being received. So business choose real-time inference when the fast response time is more important than reducing infrastructure costs. So let's move to the next slides. So now let's look at another deployment method called batch inference. Unlike real-time inference, batch inference does not process one request at a time. Instead, it waits until a large amount of data is available and then process everything together. Imagine your teacher grading exam papers. Instead of grading a one paper every time a student submit it, the teacher collect all the papers first and then grade the entire class together. That that is exactly how batch inference works. Organization collect many records and then the machine learning model process all of them in a one prediction job. Amazon SageMaker provide this through batch transform. Instead of keeping a predictions endpoint running all day, SageMaker start the job, process the complete data set, saves the prediction results, and automatically stop after finishing. Batch inference is commonly used when predictions are not needed immediately. For example, a company may want to predict next month's sale for every store. These predictions are usually generated overnight because employees don't need the results instantly. Another examples including customer segmentation, inventory planning, insurance claims analysis, and monthly business reports. The biggest advantage of batch inference is lower cost. Since computing resources are used only while a batch job is running, organization saves money. The limitation is that users must wait until the complete job finish before receiving prediction result. Let's move the next slides. So the third deployment option is called serverless inference. The word serverless does not mean the server does not exist. Servers are still being used. The difference is that organizations no longer have to manage them manually. Amazon automatically manages everything in the background. Imagine your web visit a library only once every few weeks. Instead of renting a study room every single day, you simply use one whenever you need it. That is very simple to how serverless inference works. When no predictions requests are being made, Amazon does not keep resources running continuously. As soon as a prediction request arrive, Amazon AWS automatically start the required resources, load the machine learning model, generate the predictions, and then release these resources after the work is finished. So everything happen automatically. Organizations can pay for the time their model is actually being used. This makes serverless inference a great option for applications that received only occasionally predictions request. For example, an internal company portal that predicts employee training recommendation may only receive a few requests each day. Keeping expensive servers running all day would waste money. Serverless inference solves this problem by automatically providing resources only when they are needed. One small limitation is that the very first request after a long period of inactive may take a little longer because AWS first need to start the required resources. However, many organizations the cost saving are much greater than this small delay. So serverless inference provide an excellent balance between automation, simplicity, and cost efficiency. Now that we understand different deployment methods, so let's talk about one of the most important AWS service used during deployment called Amazon SageMaker endpoints. So you may be wondering what exactly an endpoint. The easiest way to understand it is to think of an endpoint as a communication bridge between an application and machine learning model. Imagine you order food using mobile app. When you press the place order button, your order doesn't go directly to the chef. Instead, the order first reach the restaurant's system, which the sends it to the kitchen, and after the food is prepared, the restaurant sends the complete order back to you. A SageMaker endpoint works in a similar way. When an application needs a predictions, it sends the request to the endpoint. The endpoint receives the request forwarded to the deployed machine learning model, wait for the predictions, and then send the results back to the applications. This process happen automatically and usually take only a few seconds. One of the biggest advantage of the SageMaker endpoint is that AWS manages most of the infrastructure. Organizations do not have to manually configure servers, maintaining networking, and constantly monitor system availability. AWS will automatically help with scaling security and maintaining the endpoint. For example, imagine a hospital using a machine learning model to help identify possible disease from medical reports. Every time a doctor upload a patient's information, the hospital system send the request to a SageMaker endpoint. The endpoint communicates with the deployed model, receives the predictions, and quickly return the result to the doctor. The doctor receives the predictions within seconds, he- helping them make faster decisions. This is why SageMaker endpoints are used in many real-world applications such as a fraud detection, recommendation system, healthcare customer support, and demand forecasting. Let's move to the next slide. So now let's learn about another useful AWS features called multimodal endpoints. So before understanding this concept, imagine a company that has 100 different machine learning models. For example, an online shopping company may have separate model for clothing recommendation, electric, groceries, furniture, books, and many other products categories. If the company create one endpoint for every model, it would need to keep 100 endpoints running all the time. That would require more computing resources and increase cloud cost. To solve this problem, AWS introduced multimodal endpoints. Instead of creating a separate endpoint for every model, multiple machine learning model can share one endpoint. Whether a prediction request arrives, SageMaker automatically loads the required model, generate the predictions, and return the results. After the prediction is completed, AWS can remove that model from memory if it is no longer needed. This allows many models to share the same computing resources. As a result, organizations reduce infrastructure cost while still supporting many different machine learning models. This feature is especially useful for business that manages many similar models for different customers, products, business locations, or languages. Instead of managing hundreds of separate endpoints, one endpoint can effectively, efficiently serve many different models. Let's move to the next slides. So deploying a machine learning model in a not simply about pressing one button and making it available to everyone. So organization must carefully plan how they introduce new model into pro- productions. This planning is called deployment strategies. What is it? Why is this important? Imagine a bank updates its fraud detection model. If the new model contains unexpected errors and replace the old model immediately, thousands of customers could experience incorrect payment decisions. This is why organizations usually test new model before making them available to everyone. One common approach is to release the update model to only a small number of users first. Engineer carefully observed how the new model performs. If everything worked correctly, more users gradually being using the updated model. Another important strategy is called rollback. Imagine that after the deployment, engineer discover that the new model is making inaccurate predictions. Instead of spending hours fixing the issue while customers are affected, they simply switch back to the previous model. This process is called rollback. It helps organizations quickly restore stable server while engineers investigate the problem. Good deployment strategy reduce business risk, improves reliability, and help organization introduce machine learning improvement safely. Let's move to the next slides. Now let's discuss some best practice that organizations follow when deploying machine learning model. The first and most important prac- practice is testing. Before deployment, organizations should carefully test the model using different types of data and make sure it performs well in a many situations. The second best practice is continuous monitoring. Deployment is not the end of the project. Engineers should regularly monitor predictions quality, response time, and systems performance to make sure everything continues working correctly. The third best practice is security. Many machine learning applications work with sensitive information such as financial record and healthcare data. Organizations should protect this information using secure authentication, encryptions, and proper access controls. Another important practice is automatic scaling. Some applications receive very few users during the day but experience thousands of requests during busy hours. AWS autoscaling automatically adjusts computing resource based on demand. This help organization model good performance while avoiding unnecessary cloud cost. Finally, organizations should retain model regularly. Business conditions continue changing, customer behavior changes, and new data become available every day. Updating the machine learning model with recent information help maintain predictions, accuracy, and long-term business value. By following these best practices, organization can build machine learning systems that are reliable, secure, scalable, and ready for real-world use. Let's move to the next slides. So now that we understand how machine learning models are deployed, let's look at the real world example to see how everything works together. Imagine an online shopping company like Amazon. Every day, millions of customers visit the website, search for products, and purchase different items. The company wants every customers to receive product recommendation that match their interest. To do this, the company first collect information such as products customers search for, item they purchases, product they add to their shopping cart, and even the time they spend looking at different products. This information is used to train a machine learning model. During training, the model learns patterns in a customer behavior. For example, it may learn the customers who buy a laptop often purchase a laptop bag or a wireless mouse shortly afterward. Once the model has been trained and tested, it is deployed using Amazon SageMaker. Now, the interesting part begins. Imagine you open the on shopping website and search for a mobile phone. The website immediately sends you your research information to the deployed machine learning model through a SageMaker endpoint. The model quickly analyzes your search history, your previous purchases, and the behavior of similar customers. Within just a few seconds, it predicts with the product you are most likely to be interested in. These recommendations are then displayed on your screen. You may notice suggestions such as phone cases, screen protectors, chargers, or wireless earbuds. These recommendations are not selected by a person, they are generated automatically by the deployed machine learning model. As more customers use the website every day, the company continue monitoring the model to make sure the recommendations remain accurate. If customer interests change over time, engineers retain the model using newer shopping data and deploy the updated version. This allows the recommendation system to continue improving while providing customers with a better shopping experience. This example clearly show why deployment is so important. Without deployment, the trained model would simply remain stored inside a computer and customers would never receive personalized recommendation. Deployment transforms a trained machine learning model into a real business solutions that creates value every day. So let's move to the next slides. So before we finish today's presentation, let's quickly review the most important ideas we learned. First, we learned that machine learning model deployment is process of moving trained model into a production environment where real users and applications can use it to generate predictions. Next, we learned that deployment is what allows businesses to turn machine learning model into a practical tool that solve real world problem. We also explored the three different deployment methods: real time inference, batch inference, serverless inference. After that, we learned about Amazon SageMaker endpoints. We also discussed multimodal endpoints, and then we looked at deployment strategies and learn why organizations carefully test and release new model before making them available to all users. Finally, we discuss several best practices including testing, continuous monitoring, security, automatic scaling, and regular model training. Together, all of these concepts help organizations build machine learning systems that are reliable, secure, scalable, and ready for real-world applications. So that is this brings us to the end of my presentation on machine learning mobile deployment fundamentals. Today we learned that building a machine learning model is only one part of complete machine learning journey. A model become true valuable only after it has been deployed so that a real user and business application can benefit from its predictions. I hope this presentation has helped you better understanding how machine learning models move from deployment into real business environments and why deployment is one of the most important stage of the machine learning lifecycle. Thank you so much for taking the time to watch my presentation. I also want to express my sincere appreciation to my professor, Dr. Victor Swami, for his continuous guidance, encouragement, and support throughout this learning journey. His practical teaching style and real world approach to machine learning and cloud computing have helped me understand these concepts more clearly and improve my technical knowledge. I truly appreciate all the opportunity he provided provides for students to continue learning and deploying their skills. So thank you once again, and I hope you enjoyed my presentation and have a wonderful day.